All right, we'll start our next talk now. So it's always good to hear about people actually using our OCP hardware and software, and not only because it validates what we're doing, but we get good feedback. And so Matt Turner works for Qualcomm, and he's going to tell us about their deployment of OCP. Take it away, Matt.
Thank you. Hi, everybody. So why am I here? Did anybody listen to any of the LinkedIn presentations, Facebook presentations about their ginormous networks and the crazy cabling? That sounds awesome, right? I'd love to live there or work there, but I live in San Diego, so too bad for me. So the biggest company in San Diego with the biggest network that I can play with and work on is Qualcomm. So make chips, modems, RF front end sort of thing, 5G technology. So we have about 30 data centers. About half of those are small with frequently less than 20 switches, tier 1 and 2 data centers, more like server rooms. The bigger ones have lots and lots of compute for designing next-gen chips, modems, that sort of thing. So you can see 800 or so switches, spine leaf topologies mostly, and we have a dedicated net DevOps team. More on this later. So wanted to kind of, it sounds really cool, and it might sound easy for the big hyperscalers with an IT team or network 40 network engineers supporting a data center to deploy open networking on OCP hardware. But what does it look like for a medium-sized enterprise, which is what I think Qualcomm is, to deploy a white box, to go from traditional network vendor, Cisco, Arista, Juniper, that sort of thing, to Cumulus on OCP hardware. So I thought that might be interesting to some people, so let's get into it. So what is open networking? It really depends on who you're talking to, what the audience is. Could be any number of things. For the purposes of this presentation, for us at Qualcomm, that is white box switches, ONI, and software on top. There's a few of the software vendors or products that we tried out. Did a lot of testing, and it's amazingly easy to load software on these switches. We'll get into that later. So why open networking? It wasn't just, hey, this is in the news, let's go try it. We had, about 3 years ago, we had a large traditional TAP-AG network vendor in-house. So this was a traditional big box. You license it per port, and support costs were really, really high. So I got when I took over the purchasing and the renewals, that sort of thing, I got a renewal bill for 4 boxes, and it was almost $300K or something for 1 year support. And I was like, whoa, that's not gonna work very well. So started looking around what else is out there, and we stumbled upon a couple things and tested a few things, and then we landed on Big Switch, and we were basically able to replace that whole legacy TAP-AG network with all new white boxes and Big Switch software in a small amount of time for, I think, less than the cost of that 1 year renewal. So that was the main driver for us to get involved and to start doing open networking. From there, it kind of blossomed. What else can we do? What else is out there? I read about Cumulus for a little while, and I've been kind of Linux nerd for years, in addition to the traditional networking stuff. So it just made sense to start looking at it. So disaggregation allows flexibility. I probably don't need to talk to that much. I mean, with the crowd here, it's a given. Linux is easier to automate than traditional vendors, so I might be a little bit biased, but I think it's true. I mean, the tools like Ansible, Chef, Puppet work really, really well for Linux because they were developed for Linux. And the first time I configured a Cumulus switch, this was back in 2.7 code or something. It was 3 years ago. It was basically you use VI or something to edit all these files. Your resolve.conf, your ntp.conf, all these things. And I did that once, and I found I'm not going to use VI to do this anymore. So we just started pretty much day one with Ansible, and I'll talk more about that. But Using Ansible in that new approach kind of led us to this cattle versus pets change in mindset. So another good thing about open networking and using Cumulus specifically in the way we did this was we're transitioning. Maybe not all of our switches are open networking today, but the lessons we learned from this are helping us run our traditional networks a little bit better. We're treating switches like cattle instead of pets, pushing out configurations to the masses and not focusing on one switch at a time. All right, so like I said, we did a lot of lab testing and evaluation. We're traditionally a Cisco shop, and then we started doing other things, and so it's Cisco Arista and now Cumulus. And we talked about our upper management and all of the team members as well. So a bunch of CCIEs on the team, that sort of thing, traditional network guys, and it's not easy to just change gears and start going, using Linux as your network operating system. It's a big change for traditional network guys. So a lot of lab testing. We decided on Cumulus for networking and Big Switch Monitoring Fabric, as I mentioned. Cumulus has some cool features. If you haven't heard of these or read about them, go check them out. It's really cool stuff. Really like the BGP unnumbered. And the TAC is great, by the way. You guys have a great TAC. And then on the monitoring side, the Big Switch Monitoring Fabric was super easy to deploy. It's a controller-based thing. It's open flow underneath, ZTP, DHCP. The whole thing just kind of came up and very simple to manage. And we manage a pretty large network of those. So hardware. Because we're running Cumulus and Big Switch, we always make sure that when we buy the hardware, it's on both vendor HCLs. And there's a few benefits by doing that. I stock spares. I don't really buy hardware support. These switches, Acton Edge Core switches are very reliable. We've only had, I think, 2 with problems. One was a DOA, and the other one had a console port that stopped working. So haven't had to use many of our spares. Actually, we use them for lab testing and training. Many different brands of optics and cables. So before we started going down this open networking path, we were buying optics from Cisco, HP, Arista, and those are some expensive optics. When we went down this road, we immediately started going to commodity optics, and huge price savings there as well. So we're paying $15 for a 10 gig SR-SFP instead of $110 at pretty good discount. And then the hardware, one of the first things I showed my upper management when we started going down this road is it's the same hardware. So I went into the bash of a Arista box, and same thing on Cumulus, and did LSPCI, and you can see all the chips are the same, the processor's the same, it's the same hardware. So it should be the same reliability, and has been. So I kind of alluded to this earlier. It's not so easy to just shift gears and then expect all of your CCIEs and other certified network engineers to just know Linux. It's not going to happen. So we did a lot of lab testing, like I said. We have some test networks. We use a lot of Vagrant. We'll talk about that in a minute. But we decided early on we needed building blocks for success, basically a framework to install, operate, and manage these switches. So that involves ONI, Zero Touch Provisioning, which works great. GitHub for storing all of our playbooks and everything. Day one, we wanted to keep all of our software, everything, all our config files in GitHub for version control. We use Jenkins for CI/CD. Basically, it's just a centralized point for us to run our automation from, and we have Splunk and that sort of thing tied into that. And then we settled on Ansible. I like Ansible. It's easy. There's no certs and things to set up. There's no agent on the box, and Ansible works better with our legacy products that are not Cumulus. So like I said, once we learned a lot of lessons from deploying Cumulus, we took a lot of that and we applied it to the traditional networks that we have. So here's a little bit more detail on the framework, and we designed this with the security team, and so day one, this whole thing was approved, and this actually leads to more stable operations of our network than we had before. Like I mentioned, initially deployed for open networking Cumulus, and then we've adapted this to Arista, Citrix, Cisco, and a few other things. So we run our playbooks from Jenkins for a couple of reasons. We didn't use Tower. We wanted something a little bit more generic, and a lot of our software developers at Qualcomm use Jenkins. There's Jenkins everywhere, so I have a lot of support. And we have things like Jenkins as a service now, so we'll probably move this whole thing to containers on Kubernetes pretty soon, so I don't have to patch it anymore. And then we tie in Splunk with Jenkins. So there's a Splunk plugin for Jenkins. So anytime one of my guys runs any of these jobs, or an automated job runs, logs the results to Splunk, which are indexed, and then we can search through. Makes things a lot easier. And then we can also alert on certain things that happen. So what do we automate? Almost everything. So like I mentioned, we don't want to be using VI to make changes to these switches. It's not a good idea. So we use ZTP for bring up. The ZTP works great. I have an example of that in a second. Ansible for initial configuration. And then that Net DevOps team that I mentioned builds our user self-service tools. And I'm going to show an example of that in a minute. And then something we've started recently is Ansible for weekly global configuration compliance. And does anybody in here operate a network where they have compliance and they have audit people who come and get in their business? No? It's just me? All right. So rather than audit all of our switches to see if they have the right NTP servers or whatever it might be, we're just pushing this now once a week, once a month. We haven't figured out what the final thing will be, but it's a declarative global configuration compliance. So then we'll just get results from those jobs that run once a week, once a month, saying these boxes are all good, or they weren't good and now they are good. So when the auditors come and look, all we have to show them is, here's our results in Splunk from all these jobs that are running, all the the NTP servers and the ACS servers, whatever else. It's all stored in GitHub, so that's our source of truth. And do automation day one if you go down this road. So zero-touch provisioning is very simple with Oni. It's actually easier than some of the other brands. So we do zero-touch provisioning as well with Arista and some with Cisco. It's more complex with those vendors because there's a few other things you have to do. Certain protocols work, some don't, and you may have to use TFTP or something. So with this, it's very, very simple. What you see there is an example of ISC DHCP, I believe. Yeah. And we're just setting default URL option, whatever that is, 67 or something. And so the switch boots up, and it DHCPs out all its interfaces. It gets an answer on its management interface. We do all this through management, not in-band. Goes to a web server, grabs its image file, reboots, and then all of a sudden you have a big switch, monitoring fabric switch, or a Cumulus switch. And we just basically flip a knob. If I want this to be Cumulus versus big switch, I just change that knob, only select -K or whatever the command is to erase the box, and it reboots and it comes back up on that other software. So it's very easy to provision these switches. And here's an example if you haven't ever seen one of these boot up. We do MAC address reservations, so before the switch gets deployed, either one of the network guys will grab the MAC address, or the rack and stack guys will provide us the MAC addresses and say this switch is this MAC address. We go do a reservation for that, so we know what the name of the switch is when it comes up. We don't have to then go create a record afterwards. Switch boots up, reboots, and then it's online. We're probably gonna. We don't deploy switches that often, but I think the more often we deploy these, the more efficient we make this process. So we're probably going to add like a little call home or something, email notification like I'm up, I'm ready to be provisioned, and then we can hit go on the Ansible playbook and deploy the global config to the switch. All right, so here's just an illustration of the framework. GitHub, obviously, top left, the Jenkins, and then the results of that Ansible playbook. This is initial provisioning playbook. So one good thing, the traditional network engineers like I said, it's hard for them to kind of learn this stuff, but most of them enjoy it. A lot of these guys have been doing config-t for years, and this is something very new for them. They hear about GitHub, and they hear about Git and Jenkins and Ansible, but they don't usually get to touch it. It's mostly on our server side. Our server management teams use that, our application management team. So for us to start going down this road, it kind of reinvigorates a lot of people, and it's been helping with retention as well, I think. So. Okay, day 2 automation. I mentioned Net DevOps team. One of the managers, my predecessor, had a great idea years ago to hire a few developers to develop tools for infrastructure. So it started out with network, and it's kind of moved into other things, some ServiceNow stuff, CMDB, so on and so forth. But these guys basically build our self-service tools. So we do the provisioning, and we do some of the ad hoc automation with Ansible, mostly Ansible. But when we want a tool that the users are, our rack and stack guys are going to use, or our server administrators want to go and add a VLAN to a trunk or something like that, we have this team that builds these tools. So there's about 7 of them. Very lucky to have them. They're awesome guys. But this is a good example of one of the most used tools. So our rack and stack guys that are rack and stacking all these servers, they'll get a ticket, say, hey, this stack of 50 servers or 2 servers or whatever it is needs to go on this VLAN. So then they find space in the data center, they go over, plug in, they find space on the switch, they plug in, and rather than asking us to go configure that VLAN on those ports or a trunk or whatever it might be, they just go straight to this tool and they can provision all this stuff on their own. Very, very effective. And this one saves ridiculous amounts of time. You can see that some of these are green and some are red. The automation only allows the rack and stack guys to change the down ports. So we have not yet failed at the speed of automation. We're very careful to make sure we put a lot of safeguards in place. So server admins, storage admins, or rack and stack guys, everybody who uses this tool can only work on ports that are down. So sometimes that means they'll have to go, if they're going to reboot a server and maybe change its VLAN, they'll go into the out-of-band management of the server, shut its NICs down or shut the server down, whatever it might be, go into this tool, change the VLANs, turn the server back on, it comes back up, and they didn't have to wait for my team's SLA of 2 or 3 days to go change a network port. So very, very useful. We also have similar look and feel tool for add a MLAG VPC for servers. We ask that all of our servers be racked up with MLAG and LACP, but that's not always the case. Some are still single connected, which is where this tool gets used. Okay, so I already mentioned some of the obstacles to overcome. So I have this, where's my config-t in here? And I was just thinking about this before the presentation. There is actually a config-t. You just have to go into FRR Quagga. So it's not exactly accurate. But when you land in a Cumulus Linux box, there is no config-t. You're in Bash. You're in Linux. So for a lot of engineers, that's kind of a foreign place to be. So there's things that they need to learn, and that there's a ramp up there. One of the first things, so I should say, so my management doesn't see this and get upset with me, I have great managers. My immediate manager is a triple CCIE, really smart guy, love him to death. And his boss is also a CCIE, long-time Cisco guys, and they have a lot of experience. Well, with all that experience comes, basically one box, one number to call for assistance. So the first thing they ask me is, who do I call for support? Is it going to be a problem that if I have a problem, is the box vendor going to point to Cumulus point to the box vendor and have this issue? Sometimes we do have that problem on the server side. It hasn't been a problem for us specifically on the network side. Everything gets resolved very quickly. The few RMAs that we've had, basically Cisco or Cumulus TAC says the box is bad, and I take that and I send it over to the guy that I bought the switches from, and he says, no problem, we send you a new one, it shows up, no big deal. All right, so the legacy network management and monitoring tools, I had to make these new switches work with all of our legacy SNMP stuff. Syslog, not a problem, but RSA, ACS, some of the management tools that we have that go and grab all the network configurations, those don't work too well with Linux. So we had to work through a few things, but we've actually improved on our configuration management as far as grabbing configurations and then looking for diffs, that sort of thing. So we're doing more automation with Ansible on that front. And then another thing for the traditional network engineers, in a Cisco box or Arista, you have one running config file, one file that has everything to configure that switch. Well, it's not the case in Linux. You have a whole bunch of different files. So there's a change in mindset from that, where is my config file? There is no config file. You got to look at all these. And at first, that can seem daunting. But like I said, when you use automation to do this with Ansible, it's a lot more manageable. And because that source of truth stays in GitHub, and we're not having to configure it every time on all these switches, my engineers actually like it. They don't have to type in, NTP server, this and that. It just happens. It gets provisioned that way. And at Qualcomm, a lot of places have adopted OpenStack, Kubernetes, that sort of thing. There's a lot of networking in there. And I believe that network engineers need to learn this side of networking because it's becoming more and more prevalent and more complex. So OpenStack networking was pretty simple if you just did, your layer 2. Kubernetes networking is not simple because there's about 16 different ways to do it. Layer 2, layer 3, which CNI are going to use, that sort of thing. So I believe our network engineers need to start learning Linux networking anyways, and this is a great way to start learning. So how did we deploy? We did a bunch of copper networks first, our low-risk networks first. Lab environments, we did deploy a few switches in our LAN. We wanted to try out PoE, just kind of dabbling if this might work for a LAN switch as well. PoE works, voice VLAN works, basic stuff works. And then for some of our higher throughput deployments, where we have our bigger compute data centers, we don't rely on a lot of protocols. So we slimmed down, made the configuration a little bit simpler, a lot simpler actually. And we only need BGP, LACP, and MLAG, and splitter cable. So for these environments, we do top of rack 100 gig, 32 by 100 switches. We use breakout DAC cabling to go to all those servers, and it's either 10 or 25. And it's worked well, very well so far. Test network, have at least one. We're very lucky we have a small data center as a lab. So we have NetApps in there, we have servers, chassis, just UCS, we have all sorts of different firewalls, load balancer switches, and we're able to test a lot of layer 1 things. When our deployments do happen, they're very, very fast. We have to get things plugged in and up and running, servers imaged and handed over to engineering very quickly. So we do a lot of testing ahead of time to make sure that that's going to be successful. And then for learning and automation testing, Vagrant is amazing. I used to use, Dynamips, Dynagen, the older tools, Cisco tools for simulating networks. And those worked, but you had to build them, and then you had to plug all the stuff together, and then you could use ESX, but that was very difficult. Vagrant is amazing because you can have all this stuff basically up in GitHub. Your users can go grab a prescribed topology, hit run, and that thing comes up and runs. So we have one, I think I have a picture of it here. We have one that looks just like that in the picture, where it's just a couple switches and an Ansible VM. It's just a 1604 VM, and then Ansible gets installed on it as part of the Vagrant Up script. And it's super easy for everybody to run. So they can try automation here, they can simulate changes, they can do whatever they want and crash their own lab, their own laptop, and it's not going to affect our production. So, all right, lessons learned. Linux experience is very beneficial. Automation required day 1. I think I talked that one to death. Cattle instead of pets mindset. So as I mentioned, that when we started managing or deploying these switches, we used a lot of automation, and we changed our mindset from one-by-one switch deployment to a bunch of switches at a time. And same thing for, if we have to change configurations on a whole bunch of switches across the network, we don't log into each one, change it, we just push everything out with Ansible. And then switch VMs are a great learning and testing tool. That's what I was talking about with Vagrant. So Vagrant, in case you haven't used it before, is basically a tool to boot up VMs. I use VirtualBox on my Mac. So those switch VMs that I'm talking about are Cumulus anyways, is out there on the Vagrant marketplace, which makes it super easy to run. So in conclusion, enterprises can deploy and run white box switches. It's not just for the hyperscalers. You can save money by doing so. You can usher in the new era of Linux networking. I don't remember where I heard that, but it's stuck. As long as you start in the lab, start small, don't expect config T, and keep an open mind. And that's all I had. Thank you.
So there's your
That's
cattle.
versus cattle. I had to throw that up there. Any questions?
Yeah, there's a question. If there are questions, please just use the microphone so that we get caught on the recording.
You talked about, is this on?
Yep.
You talked about compliance and Ansible. I was curious, did you look at Puppet? So we dealt with our auditors and Puppet, showed them the enforcement part of Puppet, which kind of got them over the hurdle of not having to come back and check with us all the time. That was my enforcement. Does that make sense?
I think so. I think the end result might be the same. It's just a different means. So we like Ansible because it's agentless, but I think you can essentially accomplish the same thing with both tools. So what we do is we have all the global configurations. They live in GitHub, and we push that to switches. We don't push it. We basically say you shall have this configuration once a week, and if it's not that configuration, it'll change and make it so. So basically, our auditors will just look at those jobs that run, and then they'll say, well, do you have all your NTP servers set and documented? Yes, that's in GitHub over here. That's our source of truth. So I think whether I used Ansible or Puppet or Salt or whatever, I think the end result would be a declarative configuration push, and then results from those jobs serve as your proof that you are enforcing that. Does that make sense? Yeah. All right, good.
So I was wondering, what are the percentage of network switches in Qualcomm that are white boxes right now?
So we have about 30 switches deployed in production that are Cumulus, another, I don't know, 20 or 30 that are big switch. We have, I don't know, maybe 20 or so in our lab. And then we have, we're rolling out more right now, probably another 20 or 30 that are going to go online in the very near future. Oh, total
Overall
data center
percentage.
switches like 850. The last time I checked, a couple weeks ago. So it's a smaller percentage, but it's growing quickly because we're going through network refreshes, and we have basically full confidence now. Maybe not full 100%, but we have confidence now in our upper management that we can deploy these out and manage them, and we're not going to break the network. So we're deploying more right now. All righty.
All right. Thank you, Matt.